All right, I am recording now, and everybody should see the introduction to organic chemistry unit 1. Um, Guys, I'll be honest with you, this is not the most important unit. There's some information here that might be new to you, but most of this unit is from Chemistry 1121. So the purpose of Unit 1 is kind of, uh, I guess, a refresher, to get you back up to speed with this concept of organic chemistry. I know some students haven't done Chemistry 1121 maybe in a few semesters. So this will be good for anybody who can't really remember Unit 1. Oops, sorry. So the first section is, and I do apologize, this is going to be a little bit maybe boring for some of you, this first unit. The first section or sections is basically definitions, what is petroleum, what is organic chemistry, and we're going to look at drawing structures. Maybe not structures like this, but line diagrams or structural diagrams, things like this. So that's condensed structural, but we'll look at all these maybe today, maybe next class. I think we have class tomorrow. So guys, I assume you know this if you're in chemical engineering or petroleum engineering. Petroleum is the whole idea of this course. We're going to look at organic chemistry and how it relates to petroleum and the oil and gas industry. I have just had the question in the chat, do you have aromatics? Absolutely. I think aromatics is chapter 4. So we'll talk about aromatics in chapter 4. Nothing too crazy. It's not that complicated. We don't go too crazy with aromatics, I mean. So petroleum, I assume you guys know this definition. It's naturally occurring substance. It's a yellow-black liquid found in geological formations under the Earth's surface. This honestly is a definition, that you probably do want to know for an upcoming quiz or your first test. Even on the final exam, naturally occurring substance found beneath the Earth's surface. Now, in terms of chemistry, obviously, petroleum is a large mixture of different hydrocarbons. So hydrocarbons being basically chemicals that are composed of hydrogen and carbon. There are definitely other elements in petroleum products, impurities, sulfur, oxygen, nitrogen, but the primary chemicals in petroleum, especially what we're looking at when we refine it, is hydrocarbons. So alkanes, 1, 2, 3 carbons long and longer. So the interesting thing about petroleum is each variety, like depending on where you are getting the petroleum, has a unique mix of molecules. And these, we'll talk about this in Unit 5. These molecules can help determine its physical and chemical properties. So how thick it is, the viscosity, the color, things like that. But yeah, each petroleum variety, so petroleum that you might get in, say, Alberta, Canada, would be different. Oh, I hate this pen. Different than petroleum you might find in the GCC, Middle East region. So hydrocarbons, you guys should know this from 1121. These are organic compounds, okay? And they have hydrogen and carbon. Octane is one of them. Octane has 8 carbons. And it's often found in petroleum. So you can see here we have 1, 2, 3, 4, 5, 6, 7, 8 carbons, and each carbon has 4 bonds. 1, 2, 3, 4, and the extra bonds are hydrogen. So these white balls here are hydrogen. If you're wondering why I'm kind of explaining this, this would be your first lab. So just remember, guys, your lab won't start until the 3rd week. You can see your lab schedule on the course outline. Your first lab will be kind of this stuff. So again, a little bit dry at the beginning of this course, I know. Organic chemistry is another definition. So we've looked at 3 definitions, kind of what petroleum is, what a hydrocarbon is, and now organic chemistry. It's a sub-discipline of chemistry. So when you look at things like physics, biology, chemistry, there's sub-disciplines, meaning like a focus area. So in chemistry, you might have organic, inorganic, physical, analytical. There's different types of chemistries. Organic looks at organic compounds. And a really simple way to think about organic compounds is carbon-based. I just had another question about the first lab in the chat there. You are going to, well, you can build structures using the model kits. I have an app that we can use as well, so we can do it online or using your phone or computer. But yeah, we will be kind of looking at structures in the first lab. The first lab is kind of a review for, again, another review from 1121. After the first lab and after chapter 1, everything is basically new. So, and anyways, back to this slide, organic chemistry, sub-discipline. It looks at organic compounds. Oops, sorry. And these are primarily carbon-based compounds that are covalently bonded. Remember, again, this would be chemistry 1120, covalent versus ionic. Remember the difference there? Covalent, there's a sharing of electrons. And ionic, there's a transfer. So we're not really going to deal with ions or electrons. Well, sorry, we'll definitely deal with electrons, but we won't really deal with ions in this course. We're looking at covalently bonded chemicals, molecules, I should say, that are sharing their electrons. So organic chemistry, we can study structures, chemical structures, to look at their chemical composition and their formula. We can study the properties and reactivity. So properties could be things like boiling point. And boiling point is a very important concept when you're looking at hydrocarbon chemistry, or I should say petroleum chemistry, because the properties that determine boiling point are directly related to your distillation columns. We distillate or separate hydrocarbons based on their boiling point. So this is another big concept that we're going to look at in a lab as well. You have like multiple labs that will cover boiling points. I really like the labs. Other uses of organic chemistry, they study organic reactions, and you can use them to synthesize or make natural products, drugs, and by drugs, I mean like pharmaceuticals, medicines, polymers. Polymers, a good example of that would be plastic or plastics. So organic chemistry is really, really useful in the world from things like all petroleum products, pharmaceuticals, even certain things like makeup. If any of you wear makeup, a lot of that is organic chemicals or done through synthesis of organic chemicals. Kind of interesting. So organic compounds, carbon-based compounds, they form the basis of all earthly life. So plants, animals, humans, we all are made up of many, many organic compounds, extremely structurally diverse. And a lot of this is due to carbon. Carbon is a really important building block of organic chemistry. It has 4 electrons, 4 valence electrons, meaning it can form 4 bonds, which means there's lots and lots of different combinations, alkanes, alkenes, alkynes, so single, double, triple bonds. There's rings, aromatic rings. I mean, it's like the best building block you could imagine in terms of a chemical element. So organic compounds, very structurally diverse. And they form the basis of, or are parts of, plastics, pharmaceuticals, petrochemicals, foods, explosives, fertilizers, paints, all sorts of things. So pretty useful. Again, guys, really the only thing here is for multiple choice purposes, you might want to know your definitions for petroleum, hydrocarbons, and then organic chemistry. So this is the big topic for today, section 1.4. This is, I don't think I'll finish this today. I don't keep my online classes very long. It's hard to kind of stay focused online sometimes, so I try to keep them short. And I'll just kind of introduce the structural and skeletal formulas today. And basically, this will almost get us ready for the first lab, which is a few weeks away. So this section, very important section, guys. This is going to be important for the rest of the other chapters because we need to learn how to draw molecules. So section 1.4, I'm kind of going to introduce that. Okay, so again, this is totally review from chemistry 1120 and 1121. The molecular formula is a formula you guys are probably the most familiar with. We would use, or we have used, the molecular formula in your earlier chemistry courses. So 1120 and 1121. The molecular formula is good, but not really good for organic chemistry uses, and I'll kind of explain why. So the molecular formula is the actual makeup of the compound, but important, it does not describe how the atoms are put together. So look at this molecular formula here, ethanol. It's an alcohol, that's the functional group. We'll talk about functional groups soon, but you wouldn't know that just by looking at this, okay? This doesn't tell you how the carbons are attached, how the hydrogens are attached, and how the oxygen is attached. And actually, the oxygen here is attached to a hydrogen. This is called a functional group. And we're going to have to learn a lot of functional groups in this course. So aldehydes, ketones, alcohols, carboxylic acids. The molecular formula is good when you're doing balancing equations or stoichiometry or molar mass. But we're not really going to do that in this course. So the other problem with molecular formulas is they're misleading when dealing with isomers. And I'll explain what an isomer is shortly, but it's basically, or I'll explain a little better shortly, I should say. But an isomer is basically different chemical compounds that share the same formula. So you can organize these atoms in many different ways, and they would be called isomers. And if that doesn't make sense, I'm going to get into that. We're going to draw or sketch some isomers later. Maybe not today, but tomorrow. So molecular formula, it's good. It's great for stoichiometry, but not really good for organic chemistry. Or, well, certainly not good for this course. So another way to represent a formula in chemistry is the structural formula. This does display the atoms of the molecule in the order that they are bonded. So the structural formula shows you how it's built, how it's bonded and all stuck together. And sorry, I'll show you some examples of that in a minute. Not only does a structural formula show how the atoms are bonded together, but it can also show if they're single, double, or triple bonds. Again, something that's really important for the chemical properties that the molecular formula doesn't show us. In the structural formula, covalent bonds are shown using lines. So if you can remember Lewis diagrams, don't worry, guys. You won't have to worry about complicated Lewis diagrams in this course. But if you can remember a Lewis diagram, this is kind of what it looks like. And again, structural formulas, they are helpful because they explain properties and this, well, I guess I don't really need to say and structure, but they explain properties of a compound which empirical or molecular formulas cannot represent. Again, knowing things like how many bonds there are, what functional groups are on there. So an aldehyde might behave differently than an alcohol, for example. Knowing the shape and the structure of a chemical compound can really help us predict things like boiling point. And I guess that's the big one here for us is boiling point. So this is the structural formula for another chemical. This is propanol. This is another alcohol functional group because it has the OH. We'll talk about functional groups later, but this is the molecular formula. And this is our structural. All right, so we're going to, honestly, guys, soon, like, and when I say soon, I mean in the next like 5 minutes, we're going to kind of skip over structural and do this with a skeletal formula, which I will show you shortly. But yeah, the structural formula shows me that all the carbons are single bonds. There's a functional group here, OH. It's really useful. And we won't really have to draw structurals in this course. And I'll show you the reason why in 2 slides. So structural formulas, very useful because the number of dashes can show us the number of bonds. And these bonds, single, double, triple, help tell us about chemical properties. So boiling points, reactivity. So double and triple bonds tend to be more reactive than single bonds. So a lot of polymerization reactions use double bonds or need double bonds. So yeah, structural formula, very useful. But you might notice something, guys, about the structural formula. It's kind of annoying to draw, right? If you like, especially looking at propanol, if you had to draw a very large hydrocarbon, so something that had like 10 or 20 carbons, it would take a long time. So, you know, chemists are famously lazy, or I should say maybe scientists are famously lazy. There must be an easier way for me to draw propanol or octane or cyclopentane than having to draw all of these lines and all of these hydrogens and all of these C's. Is there an easier way? And the answer is yes, there's certainly an easier way. It's called the skeletal formula. And this is the big one today. Okay, definitely make sure you understand this. And I'm going to show you throughout the whole semester how to draw these skeletal formulas. I just had a message in the chat about sharing electrons. Yes, so remember, these are all covalently bonded, which means there's a sharing of electrons. So yeah, organic compounds, they can be really complicated. Just let me share another screen here. Just give me a second, guys. Let's just take a chemical. I mean, I'll take my favorite chemical ever, caffeine, right? So caffeine is what keeps you awake. It's in coffee, it's in Pepsi, you know, most dark carbonated drinks, caffeine. So let me just share my screen here. I got a Wikipedia page opened up. I'm a huge fan of Wikipedia. Don't let anybody tell you it's not good. It's fantastic. So this is caffeine. It's a nervous central stimulant, but look over on the left, or sorry, on the right of the page. Look at how complicated this molecule is. And this isn't even really a complicated one. There are much more complicated molecules. But you can see, you know, this is kind of like the ball and stick model. Imagine having to draw every hydrogen that was on this and then having to put in every carbon and every hydrogen. It would take a long time. So a skeletal structure is where we just use lines, and the only letters that you put in are things that are not carbon. And I'll say hydrogen, but sometimes you do have to put hydrogen in. So a skeletal diagram, we don't put in any carbons, we don't put in any hydrogens. We do put in functional groups or special elements, but it does save a lot of time. Let's just do another one here. So again, I love Wikipedia. So we could take something like heptane. Okay, now this actually doesn't have a skeletal structure for heptane. Let me clear my annotations here. Oh, it does have skeletal structure. Sorry, my writing was on top of it. So yeah, imagine, like, which would you rather draw? 1, 2, or 3? I mean, if I had to give you the option to draw 1, 2, or 3, I would hope you guys would pick 1, right? Much, much easier. Okay, so that's our goal for today. And I'm only going to go about 5 more minutes, guys, and then we'll take a break for today. This is not a crazy busy course. I don't know if you guys remember chemistry 1120, or sorry, 1121, how crazy busy it was. This is not that bad. So we don't have to go crazy fast ever in this course. I love it. I love this course. All right, let me go back to my PowerPoint. Okay, so skeletal formulas, they are the best. Organic compounds can be complicated. So this allows us to skip writing carbon and hydrogens. We replace the letters with lines. And it's called the skeletal because it looks kind of, like a skeleton. If you imagine a human person, but you stripped away all everything except the skeleton on the inside, that's kind of what this is. We're stripping away all of the carbon and hydrogens. We don't need them there. Yeah, exactly. So yeah, skeletal can be very, very easy. And honestly, guys, between us, I know I'm being recorded right now, but between us, the skeletal formulas in this course, I'm keeping pretty simple. I mean, really, when you're looking at petroleum and you're looking at what we get from distillation, we're typically trying to get simpler hydrocarbons from methane, ethane, propane, butane. I'm gonna try to keep this simple. So skeletal formulas show the structure and order of atoms, but we don't have to worry about the carbons and hydrogens. So this, and I'm just going to take a minute here, and I know if you guys are kind of spacing out, I just want you to look at what I'm about to do here. This is pentane. Pent means 5, okay? So this is a carbon, a hydrocarbon that has 5 carbons in its chain. Sorry, oops, I didn't mean to do that. I just got a chat message I want to read here. Oh, no, not necessarily. Sorry, just reading a message in the chat there. Okay, so this skeletal formula for pentane, it has 5 carbons in it. So how do we go from 5 carbons to this shape here? And I really wish I was in person because I like to do this on the whiteboard. So guys, just follow where you see the red. I'm making a red dot here. The minute your pen or pencil touches the paper, that's a carbon. And then I draw a line, that's 2 carbons. I go down, kind of like a zigzag. Oh, this pen's gonna drive me crazy. So 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, and it's really important to know that when the minute your pen touches the paper, you have a carbon. And then a line is 2 carbons, and then 3, 4, 5. We're going to practice this, don't worry. Isomers. Okay, here's what I'll do. I'm going to finish right now, but I'm just going to open up a blank page here. Let's do a blank or a white screen. Let's just practice a couple. Let's take some simple ones. I'll just kind of do 1 or 2 with you and maybe get you guys to do one. It's a really good idea when you come to your class or you're listening online to have a pen and a piece of paper next to you, because we will be doing practice problems together. So, okay, let's take butane. Okay, butane is 4 carbons. You guys will have to know up to 10. Just like chemistry 1120, or sorry, 1121, you should know 1 to 10 carbons, and we'll do that next class. So the structural formula for butane is really annoying to draw, especially when your pen does that. Okay. Oh man. Sorry guys, it's the pen and it's not me. I could go on a rant here about this. I'm using a Microsoft Surface computer. I'm using Microsoft PowerPoint, and I'm using a Microsoft Surface brand pen. And for some reason, and it's not just me, other instructors too, the pen likes to jump around and I don't understand. Anyways, sorry. So this is my structural. Okay, that took me a few minutes to draw. All I have to do for skeletal, and I'll pick another color down here. Let's go green. Is I put my pen down, so you see that dot. So that's 1 carbon, 2, 3. Oops, sorry. 4. 1, 2, 3, 4. This is butane. This is my skeletal structure for butane. So 1, 2, 3, 4. All right, I'm going to basically finish here, but I'm going to give you guys a minute. Why don't you guys try one? Try to do hexane. If you have a piece of paper in front of you, try hexane. And if you can't remember what hexane is, hexane has 6 carbons. Okay, so I'll just give you guys like 60 seconds or something. I'll put myself on mute and just draw on a piece of paper, if you have one, try to draw hexane. See if it looks like mine. All right. Maybe later in the semester, I'll have you guys maybe annotate on my screen. Using the Zoom app, you guys can actually draw on my screen if I let you, which has been driving me crazy in Chemistry 1120 because the students like to draw on the screen, so I've had to disable it. But for now, just because this is our first class, let's see if you guys got what I did. And I want to show you one thing before you go, because your drawing might look a little different than mine. So hexane, 6 carbons. Oh man, this pen. 1, 2, 3, 4, 5, 6. So again, count your carbons. 1, 2, 3, 4, 5, 6. Now, some of you guys might have done it a little differently. You might have started going down. So 1, 2, 3, 4, 5, 6. This is also fine. Sorry. Okay, so either one of these are fine. This, by the way, is not an isomer. And if you don't know what isomers are, it doesn't matter. We're going to talk about that next day. But just for future studying purposes, if you're writing along with me, this is not an isomer. We'll talk about that tomorrow. So that's it for me today. I'm going to hit stop recording. If you guys have any questions, you can let me know in the chat. If you have no questions, have a great afternoon or a great morning. And